All right, so we're going to move on to the last learning target of this unit, which is the modern atomic theory. So what is the modern model of an atom? The modern model, but the big thing is that electrons can only be found in certain energy levels, not in between those levels, but the precise location of electron is not easily or cannot be predicted. All right, so the electron location is limited to energy levels, and in the Bohr's model, electrons can only be in certain energy levels. But as they gain or lose energy, they can move between different energy levels. So electrons act like waves. The exact location of an electron cannot be determined. And an orbital, vocab term, is a region in an atom where there is a high probability of finding electrons. All right, so how are the energy levels in an atom filled? The number of energy levels that are filled in an atom depend on the number of electrons. Valence electrons are the electrons that are on the outermost orbital of the of the atom, and they are what control the reactivity of the atom. So there are four types of orbitals. You have s, p, d, and f, and each orbital can hold 2 electrons. Orbitals determine the number of electrons that each level can hold. Okay, so energy level 1 holds 2, 2 will hold 8, 3 is 18, 4 is 32. You can see how many is in each of those. So again, what makes an electron jump to a new energy level? Electrons can jump between energy levels when an atom gains or loses energy, and typically that energy is either going to be light or heat. The lowest state of energy of an electron is called the ground state. If an electron gains energy by absorbing a photon, it moves to an excited state. Photon is a unit of light, and we talked about that in this class already. So electrons release a photon when it falls back to the lower level, and photons have different energies. The energy of a photon corresponds with the size of the electron jump. The larger the photon, the larger the jump, and vice versa. So atoms absorb and emit light at certain wavelengths. Each element has a unique atomic structure, and the wavelengths emitted depend on a particular element. The wavelengths are a type of atomic fingerprint that can be used to identify the substance. That is the end of this learning target and this unit. So be sure you complete the form. I know this one was short, and then we'll move into some other activities to wrap up Unit 4. If you have questions, let me know.